Hi all, so let's move on to the next section, which is nothing but pandas. The next package that we are going to see is about pandas. Pandas is mainly for the data manipulation. So say you have lot of data, so how can you actually make your data in the way you need? How can you actually prepare your data and store your data in the needed data structures? How can you clean, transform and the data so that when it is going for the process or the model generation, it is actually ready? And once you get the results, how are you going to analyze the data sets efficiently? So for all those processes you require this package called pandas, and it is very fast, flexible and expressive. Okay, that means that you can use tabular data, you can see the data in the beautiful format so that everybody can understand. So mainly it is used in data science, finance and statistics and research, and pandas can handle large data sets, and there are lot of inbuilt functions for pre-processing, for the cleaning, transformations and analysis and visualizations of data, and the reads and the write can be from the CSV file, Excel file, JSON, all those things are, or you can directly enter the data. So all this ways are actually possible. So let's see some functions. So the first one is actually the pandas series. So whenever you hear the term series is actually a one-dimensional labeled array. So it is one-dimensional and it is labeled also. So what do you mean by that? Labeled means it is nothing but it has an index associated with it. So it is capable of holding, it could be any data type like integer, string, floats or Python objects. It could be any of the data type that could be actually used for storing this kind of data, and each element is actually associated with the index label. So that is the beauty of it. Okay, so when you look at here itself, you can understand that you have your data. So here import pandas is the package. As pd means you are renaming that as pd, so that whenever you have to call something like pd dot, you can just call pd dot instead of pandas dot. Okay, and this is the data. So this is your series. So the series has got one dimensional data, that is 1, 10, 20, 30, 40, and you are putting something into the series as pd dot series of data. Okay, so data is this one and you are making it as a series. So how will it look like? It will look like all your data associated with the index label. So your data will be associated with the index label. That is one thing which you have to keep in mind. And say as my system actually runs with in 64, its data type is in 64. Okay, and now let's see the next one. Next one is actually a data frame, which you will be very commonly using across all your programming that you do in artificial intelligence, deep learning or machine learning or NLP or wherever you use, because all your data will be two-dimensional and above. So it is two-dimensional labeled data. So if you want to store two-dimensional labeled data, then you will go for the data frame. Okay, so something like your spreadsheet or SQL table, where you will have rows and columns, that's all, and each of the rows and the columns will have index as well. So when you look at it, two-dimensional data here, you can understand that it's like a key value pair, that the dictionary that you have learned, right? So here name, and it is again a list, and age, you have a list, and city. So this is a data, and you are actually storing it in as a data frame. So data frame of data. So data frame of data, where can you find this data frame function? Data frame function accepts one particular parameter, which is nothing but your data, and this data frame function could be seen in the pandas. So import pandas as pd, right? We have already done that, right? So pd dot, instead of pandas dot, we are writing it as pd dot. So this is the function that we are calling, and we are actually saving our values as the data frame in df. So when you print your df, it will look like this. So it is exactly like name, age, city with an index associated with it. So it looks like a normal array, as a matrix. Okay, so you could see that it is a multi-dimensional data now. Okay, so 1, 2, 3 and 1, 2, 3. Okay, so this is how you could actually see. And now so this is exactly how you actually, because when your data is in the data frame format, it looks like a matrix, and it is very easy for us as computer science people to convert it into vectors and work on the data. So it is faster processing, right? So vectorization will be more easier. Now importing and exporting data. So in order to import the data, we have something called read underscore CSV. So I have all this particular data. So this is a data set. So when you look at it, it is a data frame in fact. Why it is a data frame? It has got all those indices. It is basically called as indices, and you have how many parameters. Make is one of the parameter. These are all the attributes. These column values are the attribute values. So you have the make. So when you take one row, you could understand that Toyota is the make and the color is white. So it's a white color Toyota car with an odometer of this many kilometers, and there are 4 doors, and its price is this one. So when you take a record, so it's exactly like your record in the database. So one row, and these are all the attributes of your data, and this is whole thing is a data frame. Why? Because it is actually having an index, and all the details are actually given as a matrix, right? So now here what you could understand is that you can read all this data from a CSV file. That is possible. And if you are simply giving df.head, what will happen? It will actually give you the first 5 rows. Okay, and this is not the df. Okay, this is just your data set. So if you print .df, by default it will be giving the first 5 rows. So 0, 1, 2, 3, 4 till Nissan it will be printed. And df2 to CSV dot to CSV means it will what will happen is that whatever be the file that you are actually given here, that new file will be created, and all this data will be outputted to this particular CSV file. So does it have to be CSV always? No, it could be Excel file. So if it is Excel file, the function will change here. It will become to underscore Excel, read underscore Excel. So like that the functions will change. That's all. And index is equal to false. That means that you don't want the index to be separately printed at no, you want, because you just want this data alone, so you don't want the index. So that's what you mean by index is equal to false. I will show you all this in the in your Google Colab also, but I'm just taking you through this initially. And the next one is actually importing and exporting data itself. So while importing and exporting, after importing and reading the data from the CSV and writing to CSV, you can perform lot of functions. So the first one is actually info. Info is nothing but it's like your describe function. That means that it will give you the complete information about your data set. Okay. So the data type, where all are the non-null counts, etc. All those information will be provided. And describe function basically gives the statistical. So statistical summary means you will get the mean, median. So it actually, so the describe actually helps you to understand the distribution of your data. Okay, I'll tell you what it is by showing you the example. And head means it will give you the first 5 rows, and tail means it will give you the last n rows. So tail of 5 means 5 rows from the last will be given to you. And this is actually the different functions. So if it is say series, okay, if you are actually printing a df of age, okay, it will return a series of ages alone. And iloc is actually giving you the integer location. Okay, the location of the data will be given to you. And if you want to slice your data and take a particular part of your data, then you can actually take this iloc of this index could be, and you can customize the index by this. And again, if you want to have a particular row with a label B, that is actually possible here. And this actually works like a boolean that we have seen in the last class. We have seen a boolean indexing, right? So if you want to do that, it can be used like that. So I will show till all this, and then we will move on to what it is. So yeah, then the next one is basically you can add the column, update the column, and you can rename it. You can add new rows. So if you want to add new row, then you can actually use pd.concatenation. So that is one thing which you could use. And then drop data. If you want to drop your data frame, then you can df.drop, means that whole data frame will be dropped. Then if you want to replace the data, then df.replace. So these are all the common functions which you have and for you to work with. Yes, so I will just show you all this now, and then we will move on to the next one. Now let's see the working in the Colab. Okay, so I have actually taken all those functions. So the first one that we are going to see is actually import pandas as PD, and we have our data, and we are actually working upon making it as a series, because pd.series, and this is the data. That data is actually passed as the parameter here, and we are printing it. So what happens, we will get the whole data itself, but along with the indexing also, 0, 1, 2, 3, that is indexing. Now the next one is actually panda frame. Okay, when you work in the Panda frame, if you could see that, see here, this is our data. This is a normal dictionary, right, which we all know. Now, we are calling the data frame and we are passing the data onto it, right? And we are putting it as in the DF and we are printing it. So when you print it, the same data, you will get it as a beautiful matrix along with the index, right? So this is exactly what is actually happening here. Now the next one is very, very important. So the next one which I am actually talking to you is about importing and exporting the data, this one. Okay, so while you are actually importing and exporting the data, actually you are reading from a CSV file. So if you are directly copy pasting this, what happens is that this is what will happen. If you are simply trying to copy this and when you run this, okay, yeah, this is already there, that's why. So one second, so wait, I will do one thing. I'll just show you how to do it. I'm just deleting this, okay, and I'm deleting this as well. I will tell you what I have deleted and how is it and everything. Yeah, so now coming back here, this is the code, right? So now I'm trying to run this code. Okay, so when I'm trying to run this code, it is actually showing me some error. Okay, so what is the error which is shown to me? The error which is actually shown to me is that yeah, file not found error. Okay, it is actually telling file dot found error. So when you go back here, it is actually showing how where all it went and it checked and all those stuff, and it's saying again file not found error, no such file or directory called cars.csv. So this is the error which we have. So so that means that we are actually running this Colab from where? From the Google Drive, from our drive, right? We have mounted it on our drive and we are in this particular session. So this session which is running is this particular session. See here, when you look at the runtime, this is actually in our runtime. This is a runtime session. This is the session which is actually currently running. So if you are having this kind of issues, that there are two ways where you can actually deal with the while accessing the data. So the first one is that you can upload the data into this particular session. Okay, I am telling like into this particular session. That means if you close this particular file, then the data which you have saved is lost. Okay, not the data that you are typing here, not your program. I am talking about the data. I mean, like say you are calling cars.csv. So in order to upload the cars.csv onto this particular session, what you have to do is that, see here, have you seen this particular icons here? In that there is one icon called folder icon. Okay, so I'm opening that folder icon, and then what I'm going, say for my processing, I have already saved a little bit over here. So this is actually, I have kept it as a I have actually saved it in the drive and then I have saved it. That's why it is seen here. So now there is a button where upload. See, when you click on this itself, it is showing like upload to the session storage. So this is within this particular session. So if you close this particular session, what happens? Whatever files you saved here will be lost. Why these files are not lost for me? Because I have saved it through the drive. Okay, so these files are available in my drive. That's why. So now I am loading my data. So I have this cars.csv. So I am just loading this particular data. Open. See here now what happened. See, the disk storage is used. If you see, this is the session disk storage. So if you see, now you have this cars.csv uploaded in this particular session. Okay, now I am trying to access this particular data. See what happened? See, it is actually giving me the complete data. So where is this data being accessed from? This data is actually uploaded to this particular session and I am accessing the data from within the session. Okay, now what I need to do is I want to .csv. I will just make it as CSV and I'm just making it up. Okay, so CSV, I'm just making it up. Say this one. Okay, to CSV, I'm just putting it as CSV. Okay, CSV. So this is the code which is here. See, df dot to underscore CSV output dot CSV index equal to false, right? So now I'm going to run this. So when I run this, nothing happened, but can you see something happened here? There is a new file which is actually here. So sometimes you will have to refresh this. Okay, sometimes you will have to refresh this to see the changes here. So now you can download this file. Okay, I'm downloading that file. Okay, so it's a normal download and I'm opening that particular file. See here, can you see this one? See, whole of the data which we have is actually here, but as we have given the index equal to false, can you see any of the index given here? No. Okay, so this data will be here. Okay, this data will be stored onto this particular session storage. Okay, and you will be able to use that during the session. Okay, now let me close this session. Okay, let me save this once again. I'm just saving it once again for the sake of it. I'm very sure that it will be saved automatically, but still. Okay, saved successfully. I'm just closing this particular session. Okay, so now let me show you this. So I'm just opening the file which we have actually opened. Then I am opening here. Can you see the file? No. Okay, so the file cars.csv or output.csv, it is not available. And one more thing which you have to keep in mind is that sometimes when you close this, immediately when you open, you will be able to still see cars.csv, because sometimes when we are working, we might suddenly touch our hand and close this file. All those things can happen. So nowadays I think Google Colab has updated this timing as 12 hours minimum. So even though you close your session, I think minimum of 12 hours this data will be there available. Okay, so now when you try to run this code, it will actually give you file not found error. But when you run this one again, it will run properly and the same output you will be able to see here. Why? Because they are different. I mean, like, it is two different files and it is already run, so the already saved data is there. Okay, so that's why you are able to get the file with the output, and you will be able to see the same results from output.csv. And yeah, so now that's a temporary way of storing the file in the session storage, right? Now there is another way. Another way is nothing but mounting the Colab. Okay, so how can you actually mounting your drive? So that means that, say you can actually put the file into the drive. Okay, you put the file into the drive and try to access this file from the drive itself, so that it's kind of more of a permanent storage. So this way, if you use it, actually it's more of a permanent storage. But for that, first thing which you have to do is that you need to mount your Google Drive onto this particular session. So how can you do that? So this is the default code for it. So you need to run this particular code. So I think I have, yeah. So this is how you will actually, so /content/drive is actually the root of your My Drive. So when you look at here, this is your My Drive, right? So this is your Colab notebooks where it is, right? So this is the drive. Actually this /content/drive is nothing but your My Drive, and this is what you are going to mount. So when you mount, you need to give access to the Google Drive. So you are connecting to the Google Drive in the specific specific Gmail address that you are actually associated with. You need to select all this and then continue. It actually gives takes some permissions, and that permissions has to be given, otherwise it will not work according to my understanding. Otherwise you can try as well. So see, now mounted at /content/drive. Okay, now what I need to do is that so it is in /content/drive, and it is inside Colab notebooks. And yeah, so I have a specific my file is inside this so 3 different files. This is my file. So My Drive, Colab notebooks, and inside the Colab notebooks I have actually made it as a folder structure. So these information has to be given, right? So now what you have to understand is that now your drive has been mounted. What is the meaning of it? Say when you look at here, your drive has been mounted in your session storage. This is the meaning of it. Okay, now what you need to do, you need to access the file. But when you are trying to access the file, okay, the path has to be correct. So here again it is telling like, no, I went through all these paths and I am unable to see this cast.csv. Yes, because why? I have actually added lot of say I have actually changed the location a lot. So this is my drive. In the my drive I have to go to the Colab notebooks, then I have to go to this one, then to the week 2 to access this particular file. So how can I actually access the file location? So the easiest way to access here is you can go to the drive, and in the drive it is my drive, then you have Colab notebooks, then you have this one, and this is your file location, right? So now when I am actually copy path, I am copying the path, okay, I am going back here and I am just pasting it here, okay. So this is my path now, okay. Now when I am trying to run, it will run. Why? Because now I have given this whole path. So content is my root and it is actually upon the drive, and in the drive I have my drive, then Colab notebooks, then IT7009, in that week 2, in that cars.csv. So this path has to be given appropriately, otherwise you will not get the right path, okay. And now what am I doing? I am actually printing the df.head. So what happened? So now what happens is that I have actually given this sorry, I got the first file the data from within the cars.csv. Now again I wanted to tell you one thing, which is nothing but, now I want to output this file. So if I am trying to output this, this should also work, but I want my file to be, this will work. Why? Because it will just store outside my drive, right, like this, okay. I don't want that file to be stored like that. Instead I want my file to be stored in the drive in this exact location, like in my drive, in Colab notebooks, and here, because I don't want any more confusion, right. I want the file to be stored here, or if I could say that I want that file to be stored exactly inside this. So what would I do? So I need to give the right path. So I'm just copy paste, I'm just taking all this path here. Second. So I'm just taking this path till here, till Colab notebooks, and I'm just pasting it over here, okay. So now in the content my drive Colab notebooks, exactly, right, this is where it is. So now let me run this. So now if I refresh here, so this is the location where I want my file, yes, output.csv. Now I will go to my Colab here and I'm just refreshing this here, yeah. So now I could see output.csv. I am just opening this output.csv. I could see this data which is actually stored over there. So now when you go back here and if you want to download this, I can download that. This is from the same location. I'm just, this Google Drive and this session drive which you are seeing here are all the same for this session. So now when I open this, now you will be able to see this data, okay. So these are the two ways in which in fact you can actually use, or you can actually import your data in your session. So one is directly by importing it from here, okay, and second one is by mounting it on the drive. So when you are mounting it on the drive, it is kind of a permanent storage, okay. So even though you close this session, what happens, the data will be there in your drive, okay. So that is how it is. So when you have, when you want any specific output to be saved or something like that, then it is better to mount the drive and then use it, okay. So this is kind of for the permanent storage. So I would say like it is for permanent storage, okay. So if you want to permanently store it, permanently store in the G drive, you can use this mounting technique. Or if you want to use it in a temporary fashion, you can use this one. This is to store in a session which is temporarily. This is exactly what I want you to tell here, okay. So this is fine. So now you know how to store the data, so that is awesome. And now we will move on to the next one, that is trying with the different functions inside the pandas. So to try different functions inside the pandas, the first one is actually the info function, right? The first one is info function, so it gives you about all the infos, what are the data, what are the data types, and all those memory usage, and all those information is actually given to you. Then comes the this is described, so this actually gives you all the information with, but in a more nice manner, but this actually gives you more of a distribution. So what do you mean by distribution? So the count of the data, how many count of the data is there, what is the mean, what is the median, what is the distribution, and what is the minimum value, what is the maximum value. This is called as a quartile function. So this is called as basically the 5-point summary. So this gives you the distribution or 5.5-point summary. This is called as 5-point summary data. So basically it gives you the distribution about your data, how your data will look like. So when you have a proper mean, you will understand that it is more skewed or not, or how the data distribution itself is. So for that, and you have this head will give you the first 5 records, and tail, if you simply give the tail, it will give you the last 5 records. And if you want to give, like, 2 records or something like that, you can give the value over there, then it will give you only that pretty number of records. Now again, you have a little bit more functions, which is actually the df of, I mean, like, say if you want to get a series of age, then it will simply give you the series of age. And this is very important function, which is nothing but iloc. Iloc is a very important function, because iloc is one function which actually works with the location of your data. So the first row, so if you are actually giving 0, this actually means that in the location of your data, you take the first row by integer location. So what is the first row by integer location means? First row by integer location is nothing but this data. Okay. So this is again going back to the Alice and Bob. So this is your data, right? So that data has to be actually printed here. So this is exactly what is actually shown here. And so you have the name, the age, and the New York, and all those 3 information about the first row will be actually given to you. Now upon the iloc operations in the data frame, you can actually apply the slicing operations also. What do you mean by that? The slicing operation is nothing but 1, 2, 3. That means that the 0th row is not included here. You are slicing, you are ignoring the 0th row, and first row to the 3rd row, I mean, like, first and the second row will be printed, in fact, because we have only 3 data, right? And this is like, if you want to give some custom labels, so you are redefining your index. You are redefining your index as A, B, C, and if you are trying to get the location of B, it will give you the second data. So here, if you see, it is here I'm just going to do it. 1 second. Okay, let me try to explain you what happened. So say if you are giving here I, okay, the first one, let me just explain this. Okay, so if you are actually using iloc is mainly for the numeric index. So here it is actually the values which will not be mapped. Okay, that is one thing. And here the error which is actually they are showing here is actually length mismatch. Okay, so expected access has 9 elements, new value has only 3 elements. So you know what's the issue? The issue is nothing but we've been using the cars.csv file. So the cars.csv file has got 9 indices, right? So that's what the major issue was. So what you have to do is that you have to either update this particular value to 9 indices, and if you try now, it will show you what cannot index by location, index with a non-integer key. So what is that? Because I have unfortunately given an I here, because this I will work only for the numeric indices. So if I take this out and if I now try to work, yes, it will give me the data. Okay, so now I am trying to address this B. So B in the second one. So when you go back here to your cars data, if you go back to the cars data, you will understand that what is the output that you have actually got here. The output which you have got here is Honda, red, and all those information, right? And the cars data, if you could see, in the cars data, if you could see, the second one is basically Honda red and all those information, right? Hope you are able to understand. So this is nothing but you are changing the index. Okay, you are changing the index to a particular label. Okay, you are changing the index to a label. So this is the issue that you have actually gotten. So you have to change all this. So this, I'm just keeping this here, let it be here, because this is an error. So this will actually help you to identify how to deal with the error, how to deal with this error. It uses cars data set which has 9 which uses actually the indexes, index 0 to 9. Okay, so yeah. Okay, now it's more clear, otherwise it will be more doubtful. Okay, so that's all about that. And after coming back here, then again we are actually importing the same thing. This data is actually now Alice and age and the city, and you are running this. Okay, so this is your data set now. So just to have a clear idea about it, say if you are just giving iloc of 1, what will happen? It will take you the first row. Then this is a slicing operation, so you will take the 0th row, okay, and the first row. So this is slicing operation that we have seen. Then iloc of 2 1, that is also possible. So but here what this is a slicing operation. Here you are giving 2 comma 1. So what is actually happening, you will go to the second row. Okay, you will go to the second row. In the second row, which one you want? In this row 2, you want column 1. So row 2, this is your row 2. In the row 2, you will go to the column 1. So this is your column 1. So this particular value will be printed. Row 2, 0 1 2, this is your second row. In the second row, you are going to the this particular value. Okay, so that value will be printed. So that is nothing but this one. So you can access the data within the data frame. A particular value from within the data frame is also possible with the help of the iloc. Okay, and you can actually, if you want to select specific rows and specific columns, say first 3 rows, first 2 columns, you can actually give like this. Okay, this is also possible, and this is exactly like how we have actually seen the reverse indexing. So if you are giving -1, it actually gives you the last value. Okay, so all those things are basically possible. Okay, I'll just print all those so that you will get the complete idea about it. So this is your iloc of 1. Okay, so iloc of 1 will give you the first thing, and then it is iloc of 0 2, so it will be printing the next 2 values. Then again, if you could see, this is actually 2 1, so 35 will be printed, right? And then it is about the rows and the columns. So the rows and the columns are printed here, right? So this is exactly, and this is the last one. So the last one is about all this David and blah 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 40 Miami, etc. So these are the answers. Okay, so now when you look at it, you will get a clear idea about it. So now this is the age, this is about how you can actually do the Boolean indexing. So in the Boolean indexing, it's exactly like that. So df of age, if you could see, you are actually checking whether each and every data and whichever is true alone, that you would take and you will actually print. Okay, and this is again df of senior is equal to df of age greater than 30 and print x. So this is also, so I mean, like you can also do this, and whichever is actually positive and true, that alone will be taken and printed. And now the next one which I want to tell is just to make sure that it is more clear for you. So in this example, what we have done is that we are taking the df of age, right? Df of age is actually taken, and this is the Boolean indexing. So we will take that, and we will actually check whether that is greater than or equal to 30. So in fact, you will get a complete understanding, like this is the first condition check which is happening. Now we are actually filtering it and we are putting it into the adults, right? So whichever is actually the age is greater than or equal to 30, that alone will be actually printed here, right? Only the rows with the age greater than 30 will remain. So this is what is actually happening in this Boolean indexing which we are actually using here. The next one, if you could see, you are actually creating another data frame itself, or you're adding something onto the data frame if the age is actually greater than 30. So when you look at the results here, you could see that there is another the column which is actually added here, right? So what are we doing here? This is our data frame, right? And when we normally print it, you will get like this. So that means you will have three different columns, that is name, age and 30. Now our condition check, basically what happens is that we need to check whether the df of age is actually greater than 30. So here what we does is that we are actually doing an vectorized element wise comparison. Okay, so that means we will check whether the condition is df of age is actually greater than 30, and we will print the condition. So what is our condition? Condition will be true, true, false, or whatever it is, according to whatever it is. Now we are actually assigning that condition onto df of senior. So this will create a new column named senior. Okay, if it is already exists, it will it will be written over there. So the condition will be like df of senior, where this is, so this condition whichever is met, that would be actually taken and it will be put under df senior. So when you look at it, your next one will be a senior column will be generated, and the data will be outputted for those entries whose age is actually greater than 30. Now again, this is almost very similar only, but only thing which we are trying to put is that how can you actually drop it? Okay, so for dropping it, so you are actually creating a new column senior, and the second one is basically I'm just taking this out here. Okay, I'm just taking this out. I'm just putting it as a as a new, not here, here as a new code, and I'm just putting it over here. I'm just running it again, and I want to print a df. I want to print the df, and if I do that, just a second, sorry I didn't run this, so I'm just running this again, so that now senior is actually added. Now I'm going back here and just running the drop senior. Okay, access 1 drop senior, so I'm just running it again, so the senior will be dropped. So this is one thing which you can actually keep in mind for adding a column onto a data frame and dropping a column from a data frame. So now let's see a little bit more about this add columns, etc. A little bit more. This is exactly what we have seen here, but we are just going through one simple example. So we are taking the data frame, the Alice data frame here. I'm just running it again. So this is your whole data frame which is there. And now what you could do is that you are going to add the data. This is exactly what you have seen. You have already seen this. You are adding country and you are adding USA as the country. So adding a column, you are updating the value. If you can you update any of that particular value. So if you want to update the value of one means Bob now it is 30, but you want to update it to 31, so age is now updated to 31. Now this is again the same thing only, but this is we are actually using the vectorized operation, so it will take as together and will add 1 to now Alice is 26 here, Bob is actually 32 here, Charlie is actually 36. So we have added for all the values to all together. So it's a vectorized operation. And then when we are trying to rename the column, say here, so column's name. Okay, instead of name, I want it to be as full name, and city, instead of city, I need to be as full home city. So this is possible by renaming the columns, and you can add the rows. Okay, how can you add the rows? So you are actually adding new row, pd.data frame, you are adding each one. So this is like you have actually learned in your database, right? So you have to actually give the home city, all the key values has to be given, the key value pair has to be given, and you are actually concatenating it along with the new row. Okay, and you are also ignoring the index equal to true. That means we need the index. Okay, so this is how it is. So in the new row will be added as David 001, and this row will be actually added here, right? So this is something which you could actually see. So I have already done it before, that's why it's actually, so maybe what I could do is that already I have run it once, so that's why actually it is actually giving you the two different rows of the same values. Okay, so now when I run this here, so you will have David 001 twice, because I've already done it twice, and now I have added this particular values. Okay, and then this is about if you want to add it in a particular location. Okay, so I'm just adding it in a particular location like 23, and already because I have added one location like that, so I'm just adding a new one. In the location, maybe I will add it in the location 5. Okay, I will add it in the location 5, and I'm trying to add it, so it is actually added as the last location. Okay, now if I want to drop a particular column, it is actually possible, I'm dropping it, right? And now if I want to drop a particular row, that is also possible. Say if you want to drop, say 4, okay, I will drop 4 and try to drop it. So one of the David is actually dropped. Okay, and now this is actually replacing the data which we have just seen, but you can actually replace it, the LA with the Los Angeles, something like that if you want to. That is also actually possible. Say Los Angeles, so I will put Los and A. So this is, I'm replacing it, so it will be actually replaced with Los A. Okay, so these are all the various functions that we could see in Pandas. So in Pandas itself, I understand that you have a lot more to learn and lot more to study, and you can actually, there are so many functions available in Pandas, and a little bit of a time actually took in for us to identify like how can you actually access the data, from where can you can access the data temporarily by uploading it onto the session, or by putting it onto the drive itself. So this is more permanent way of storing things. And then we have this ilog function, which is nothing but the numeric index, and you also have this label index, which is lock is nothing but the label index, and you can add the value, update the value, delete the value, update the rows, update the columns. All those things are basically possible by using various operations in Pandas, right? And data frame is a major concept that you have actually learned, where you can store two-dimensional data, and series is the data, it's the a data structure where you can store single dimensional data, right? So this is all about your Pandas. If you have any doubts, so try to make your hands dirty and work more onto it, then you will identify and make mistakes, and again stand up from where you have made the mistakes and keep moving on. If you have any doubts or anything like that, you can always get back to me. Thank you.